Hey everybody. Hopefully you're here to understand, particularly in an event-driven context, how we turn business processes into kind of software. We've got quite a lot of slides, so I won't linger on this. It just says that I'm old. I've been doing this for a while. Any .NET developers in the room? Oh, a few of them. All right. As I work on Brighter, which is an open source messaging framework. We are an alternative to things like mass transit, which is now going commercial. We are as old, if not slightly older, as a messaging framework. All right, what's the agenda? We're going to talk about how we discover business processes. So the first thing is to look at techniques we can use to work with the business to understand what the business processes they have are. Then we're going to look at documenting business processes. We're going to look at ways that we can effectively record those and understand them. I'm not going to cover service blueprints today. There's just not enough time in today's talk. And then we'll look at automating business processes, what your choices are in terms of automating them. We will use a slightly contrived example called pizza shop. So the idea is somebody wants to order pizza from a pizza shop. They will create their pizza order. They will send it to the shop. The shop will decide whether it wants to accept or reject it. It will cook it. It will arrange for a courier. Courier will pick it up. And essentially send messages to the customer saying, I'm on my way, until they finally arrive. We do have, from another talk I gave on my GitHub, Ian Cooper, there is an example basically in some code of this working, but that's not really the point of this talk. All right, how do we discover business processes? Or even perhaps first question might be why would we care, right? So often what happens in software is the developers and the product team sit down and they say something like, oh, well, we need to write some software to basically take orders from customers for pizzas. And off the developers go, oh, I'm going to build an API. Fantastic. That's going to have probably an API for a pizza, right? So I must need one of those pizza things, etc. And the problem is what they've not really done is talk to the business about what happens when we order pizza? How does this process all work? What will you do? What do I need to automate? And ultimately, most of what we really are trying to do in software development is automate somebody's business process for them. That's kind of the meaning of what we do, right? So we don't want to go straight to the implementation, because that often results in a very strict misalignment between what the business is thinking about and what we as developers are thinking about, right? And the consequences can be bad. So things like event chaining, pinball, they're often consequences of us failing to think about processes when we do our work. And so discovery is a really important step. It helps us to start thinking about the world of business processes that we're automating rather than the world of things, if you like. All right. So our goal is to understand the work. There are various ways that you can try and discover business processes of people. Value stream mapping is kind of the most kind of old school. Six Sigma people tend to like that. Event storming is probably one that I thought at a conference like this, most people have probably tried to use. People have tried event storming in the audience? People tried value stream mapping? It's just as a... Okay, probably worth having a look. Domain storytelling. Who knows about domain storytelling in the audience? A few of you, all right. So we'll get into domain storytelling a bit. Just because it's probably, if I told you about event storming, you'd be like, we already know it. So the idea behind domain storytelling can be pretty much summed up as this. People tell stories about their work and you draw a diagram to display it. I think of domain storytelling as really literally being the modern iteration of how we used to do use cases in the past, and think about capturing the use cases that customers have. And so it relates a lot also to the idea of user stories. So they have a very strong sentence structure, which is you have an actor. There's a person or a machine. It can be sort of ill-defined. There's a work object, something they are working with, and they perform an action on that work object, right? And so you can express most things in combinations of those sentences. And if you like, you can think about this as the classic description of what the steps are in a given use case. It helps with a shared understanding when you start to build these things. It helps us to understand the language of actors and objects and activities that exist within the domain. Right? It's done visually. We'll show you some diagrams in a second. You tend to use a classic iterative approach, sticking things on whiteboards with post-it notes to try and map out what's going on, but you can also do it quite verbally to begin with. And it exists in a number of pieces. So actors, right? So you tell the stories from the perspective of actors. We're always asking what the actors in the system want to do. And that may be a person, it may be an organization, it might be a computer system. There are different ways of doing domain storytelling. One way is called pure, and one way, the pure way, you basically ignore the existence of technology. And you say, I'm just going to think about this in terms of people doing manual things. And that's actually quite a good starting place, because when you remove technology from the equation in discussion with your customer, with product people, then it tends to remove that whole rush to implementation, and also from customers sort of trying to do implementation when they're describing stuff to you, and get back to what do you actually do here? What is the process, right? Work objects, so you still tell stories about things, right? And they be used, destroyed, exchanged, and generally, basically, they're part of the domain, right? But the idea is also, to be clear here, is you are acting upon those objects, right? And so these activities are things you do to objects. Generally, you put an actor on a diagram once, but you may repeat work objects between activities just to keep your diagram clearer and simpler, right? So you say the actor's going to do this with this work object, he's going to do that, and it may be with the same work object, but you're going to separate those out to make your diagram a bit clearer. And you may find that you do something with a work object and another actor does something with the same work object. So you have some kind of handover, right? I send you an order, you receive the order. All right, so I'll show you there's a nice tool for doing this, which you just go to. I don't know why it's called Egon. There's probably a reason I don't understand. Egon.io, and you can effectively you can use this to enter most of your diagrams. Now, the nice thing about this tool is it's animated, which means that you can have conversations. Can you see that at the back or on those screens? Is that all right? Okay. So effectively, my pizza shop puts up a menu. My hungry customer browses the menu. They choose a pizza. They configure the options on the pizza. They put it in a basket, and effectively we check out that basket at the shop. We get a bill, which we then agree to pay. The credit card's slightly off the screen, and that results in an order. Our pizza chef cooks the pizza. He basically assigns the work to a courier. The courier decides whether to accept or reject that assignment. They again drive over basically to collect the pizza from us, and then they basically tell the customer about their progress as they're heading towards them with their pizza in hand, and eventually they deliver the pizza to the customer, right? So that's a fairly, I mean, obviously your real world examples would be much more complicated than this, but we would just get lost in the detail. But you can see how it's quite neat in the sense that we have this notion of a customer, the customer's dealing with work objects like browsing a pizza menu, selecting a pizza, configuring a pizza, checking out a basket. In the same way, you've got a chef who's basically taking an order, cooking a pizza, arranging a courier, etc. So it's a reasonably intuitive way, and it doesn't push you towards implementation. Some of my problems with event storming is it tends to lead you towards thinking about implementation. You start thinking about aggregates and you start thinking about things, right? But what you're doing here is you're saying with the business, okay, what is it you do? Can we model and map that out before you build something? All right. Let's go back to the slides. Okay. So what is this domain storytelling teaching us? It teaches us who the actors are. That's going to be important. We're going to talk about that later. It teaches us where the handoffs are, right? Where things seem to end and move to something new. Like, so there's obviously a point where we've checked something out, and then there's an order which goes to the restaurant. There's obviously a point at which the pizza's been cooked, and that's handed off to a courier. So we can see those kind of handoffs. That's important to us. And we can think about dependencies, right? We can't deliver a pizza until it's been cooked. And we can also think about failure. So domain storytelling typically tends to focus a lot on happy path for reasons of reducing the complexity of the conversation, and because also I think they're reasonably right in observing that, software engineers like to get stuck in the weeds of how will this fail, rather than work, and the business tend to get less interested in that. So you're trying to work through the process of the business understanding their domain but more. Okay, and we'll see how these all get transferred into things later on. All right, so having done that, what I actually like to do is think about how I could turn that into something which will give me more information about what are the business processes that I'm trying to automate. So I've taken to using recently a bit of an old school tool, BPMN, for want of really anything kind of better. You can use things like UML sequence diagrams or even communication diagrams if you prefer to do that. I think they are less rich, but for some simple cases you may find them easier, or you can scratch your own notation if you want, right? But this also will tend to work, and we'll talk a little bit later about workflow engines. You will find things like BPMN tend to work with workflow engines. And you may find if you've got business analysts in your organization that they have an understanding of BPMN and tools like Archimate to draw stuff up in. Some of the diagrams in here I just use Draw.io, so it's pretty available. So this is essentially what a BPMN diagram looks like. This one's really just for a process of effectively choosing a restaurant, adding a menu items into a basket, and then effectively checking out. You can see that we have an event. Now, we have to be careful with an event-centric context. Event here just means something that happens, right? So a signal of some sort is received. It doesn't necessarily mean something flowing over a queue or a stream. And you have a start event, and we have an end event. This end event, effectively, because you can see the message symbol in it, that actually does represent we are raising a message at the end of this particular flow. Right. So a task is where you get work done. Now, typically, tasks are carried out by somebody. It might be a user doing something manual. Here you can see we've got a person icon. It might be that you make a call to another service, and the service does something. Often when we think about implementation, at BPMN diagram, we rely on a lot of details. When you get to your code, you don't typically want to build how it's done into the workflow. The workflow tends to be separated from the thing doing the actual work in the task. This is called a sequence, and those arrows show a direction of travel. So we do enter location, choose restaurant, add menu choices to basket, and we create the basket. So the key elements of diagrams, you can see there's a start event, a sequence flow, so activities. So activities are a task, which is the atomic unit, or a sub-process, which basically says there's a complicated sub-bit going on here. I don't want to show it to confuse the main diagram, so I'll basically indicate that there's a sub-process, and you can go look at the sub-process elsewhere. So for example, quite often when we draw diagrams internally where I work for kind of e-commerce, the kind of basket pricing loop is shown as a sub-process that you effectively go away from the main diagram to look at the detail on that, right? It just makes the diagram simpler. An event, so an event is somewhere where effectively you are paused, waiting for something to happen. A gateway, which is effectively where you are taking a branch, right? So there's a branch in your workflow, and the gateway controls how you decide what branch or branches to take. And also you can see at the end there's a gateway suggesting that you can also merge branches, right? And an end event. Typical tasks, I won't call them all out, but you can see service tasks, the second one down. Service task is this idea, I call a service, which is doing the actual work. Very common. Often what you've got inside code in sort of workflow engine is what we call glue code, which is stuff that's basically making these external calls. A receive and a send task you can see there. So that's really about sending and receiving messages. You'll note there is basically both a receive task and an event which can have a message in it. And really it's more to do with whether you're trying to signal in your diagram, I wait for some external stimulus before I continue the workflow, as opposed to more generic sort of messaging. Manual tasks, business rule engine, script tasks. Loop is an interesting one. Basically, you see that symbol occasion. What that means is we keep doing this task until some condition is kind of met. And transactions also a useful one. This basically represents an ACID transaction. Right? Events. So none basically just means there's no real defined trigger for it. Message basically means a message is triggering this. Timer, common one, right? Time passing will trigger this event. Other ones to note, a compensation event right at the bottom. That basically says, in the event that there's an error, do this thing. And parallel event, plus on the other side, indicates basically you're going to basically split something. And a cancel event where effectively you're saying this would end or terminate the flow abruptly. Gateways are probably what you expect. Exclusive, you can also see it with an X through it. Says either or, so tick one left or right, pick one branch. Inclusive says I will evaluate some condition and we'll take one or more branches. So you may run in parallel, right? So it isn't necessarily an exclusive or, it could be an and. Parallel split says I'm going to split into a couple of paths. Complex is, I can't describe this in a simple diagram item. Please ask me later. It's a bit of a get out of jail one, that one. An event indicates that some event arriving is what causes the gateway to change. Sequence flow and message flow. So message flow is an asynchronous flow, connecting objects. All right. So one of the things to understand is that a process is basically a sequence or flow of activities for carrying out work, right? So it's a graph of flow elements, a sequence flow, and it's a set of activities, events, and gateways. So we're describing a given flow. And it's important to understand that's effectively an orchestration, right? So there's a notion in BPMN of a token. And the token is, if you like, state for a given instance of that workflow that's running that essentially travels down that workflow in steps. And so one of the clear ideas about an orchestration is this idea that an orchestration has some kind of state and you are managing where in the workflow you are for a given instantiation of that workflow. Typically, and we'll talk about an exception a bit later, you tend to have basically this orchestration in an address space, right? So within a process, it's not distributed across processes. So typically, orchestrations are not distributed, all right? That has some consequences for where we think about things, which we'll come back to later. So orchestrations are really from a single system's perspective. They're like writing a script, basically. Typically, with an orchestration, you can think about it in terms of an actor. So remember earlier on, we were thinking about actors in terms of domain storytelling. Typically, you're thinking about an actor who is effectively performing the orchestration. Includes control for certain decisions and is local to the orchestrator, right? Often implemented via state machines and workflow engines. So here we have two orchestrations, and they're represented by what we call pools. So those big fat boxes that are holding all of the elements of our sequence flow is called a pool, and that is an orchestration. So you can think about it working like this, right? I start shopping, so you can see a little human being, and so we spin up a token representing effectively my session, and I give you my location and say I'm shopping and I live in South London, that's right. And the token is now going to track my progress along the flow, right? So now I'm effectively choosing a restaurant. When I choose a restaurant, so I work for Just Eat Takeaway, what we tend to do is create a cart for you now to shop from that restaurant. So that's going to start another orchestration. And that's effectively, we're tracking state for you in that orchestration as well. So you're going to effectively start choosing menu items. As you choose menu items, we will validate and price your basket. Eventually, you will choose to check it out, and we will effectively validate where we can deliver it. We will validate basically your payment and check you out. So we're running two different orchestrations in parallel. And you can think about the fact that we've probably got entirely different processes and threads of execution running here. So how do we find these orchestrations? So if we go back to that domain storytelling diagram that we created earlier, you can see that here we have really an interaction with a customer. We're going to ignore the customer a little bit because that's a kind of human being, with this kind of pizza shop. One, two, three? Okay, cool. I borrowed his, so. Yeah, so you can think about effectively the pizza shop as having an orchestration, where effectively it's letting people browse pizza menus, select pizzas, configure the pizzas, stick them in the basket when they're done and pay for them, right? So I can model that orchestration in BPMN, right? So you're going to come in, you're going to browse the pizza, add the pizza to the basket and configure your pizza. There's a choice. Do I want more pizza, or is one pizza enough for me? Right? Am I feeding an Amazon pizza team? Right? And then I can check that out. And when I've checked it out, then essentially I'm going to wait for my pizza. So you can see there's a little bit of a branch. Either my pizza becomes before I worry about it and I start eating it, or effectively after a certain amount of time I begin to fret, where's my pizza? And I start calling the restaurant and say, I ordered pizza, where's my pizza? Eventually, I will receive the pizza and eat, or effectively the pizza company will say, you know, there was a terrible accident, your pizza is spread across the motorway. So that is how basically order pizza. And this is an orchestration, right? So you're typically, this is running inside a process. Now, it doesn't mean that things that happen don't happen in other processes. In any one of these boxes, you may be calling something else to do work for you, but the orchestration lives within a single process. Similarly, when I think about my pizza chef, basically, who is cooking the pizza and arranging the couriers, I can think about effectively a pool where essentially that relates to the chef, and he's going to accept or reject the order depending on how much stock we've got. And then in parallel, he's going to start cooking the pizza and arranging for a courier to come and pick it up when it's done. And you notice I've got a little box, 2 boxes here. They're lanes, and they effectively let me have parallel activities. So the other lane is essentially happening in parallel with the first one. Okay. And essentially I could then have a courier whose job is to collect the pizza and signal to the customer. So basically, when I get a message from the pizza restaurant, I just say, oh, I'm on my break now, or no, I can take the job. When I'm told the pizza is ready, they say, basically, come collect it now. I go and collect the pizza. I take the pizza to the customer, and I'm signaling, we haven't really shown that here, signaling to the customer effectively that I'm on my way, all right? So I could stick it in one big diagram and say, actually, you know what, I'm going to treat all these separate things as lanes within my overall pool. But that's going to be a bit problematic. We end up with basically what we call a process monolith. And a process monolith, by implication, is also likely to lead to you creating a monolith in terms of software, right? So there's a quote here from a book called Practical Process Automation, which is a good book. I recommend you read it if you're interested in this topic. You need to avoid designing an omniscient process model that needs inside knowledge of different contexts in order to function. Instead, process models must be owned by exactly one context. It means bounded context. Process models are domain logic and thus should be contained within the service implementing the respective context and apply the ubiquitous language of their context. So we can find the bounded contexts that relate to our story because of domain storytelling. So typically the advice domain storytelling gives about finding bounded contexts, one where's the group by actor. That's very useful to us if we're trying to basically organize our system around automation of processes, because you can but the BPMN pools tend to be related to an actor. So that's a really good place for us to start looking if what we want to do is to find bounded contexts that are oriented around a process. One-way information flow often is a reason to have a separate context. In other words, I deal with a whole lot of work objects, but I don't really deal with anybody else. And at the end of it, I have some kind of handover where I go, having assembled all this stuff, I give it to you. Different triggers, so different reasons why effectively this whole process runs and gets started. Activities supporting something not in the picture, that typically means, I call out to an external payment provider or something like that. Differences in language, well, that's a classic DDD one, right? We essentially say, we talk about we have different words for these things. Maybe we are therefore in different bounded contexts. And similarly with synonyms, right? We have the same word, but we mean quite different things by it. So, I mean, a classic one in this kind of process is when people talk about orders, right? For the customer, order means quite a different thing, potentially, to the kitchen, for whom it means actually a request to cook, or to the courier, for whom it means a request to deliver. And so those things essentially are quite different. So we can look at this example again, and actually the BPMN diagrams we drew give us quite a strong hint. We can think about having separate bounded contexts around really your shop, where effectively you're configuring, ordering, and placing pizzas and paying for them. You might separate out payment, right? But it's too simple an example here. But in reality, you could. Your kitchen, effectively, where your kitchen is cooking pizzas, taking orders, arranging for couriers. Again, possibly if it was a really complicated domain, in reality, you might separate out the arranging of couriers and your courier themselves, who is effectively taking stuff to be delivered. So that gives us these bounded contexts, which tend to mean we tend to have separate processes holding the different workflow engines or state machines or handlers, we'll get to that in a second, that are running individual processes and call various services they need to operate. So collaboration is focused on how these different contexts interact, right? So it might be with some centralized workflow engine, though that tends to couple us to a central workflow engine because all of the flows need to run in the same engine. So we'll come back to that a bit later. It might be with an API, all right? So we might be calling an API running somewhere else because we have a method, one of our tasks says, call this API, get a result, and come back. It might be sending a message, right? So under that API, we would count sending a message. So here, when we go back to that example we showed the tokens of earlier, we can see that these interaction between these two pools, which would be two different bounded contexts, which are therefore at least two different processes, is where effectively we have collaboration. And collaboration is where that term choreography fits in, right? The choreography is the stuff happening between the two orchestrations. While somebody owns the orchestration, the person that owns the process, that owns the state of the given instance that is running through that particular orchestration, nobody owns the collaboration. There's no one tracking its state or what's happening in it. This is what we end up with, don't worry, you don't see the detail of the diagram, when we think about the three pools as three contexts running separately in terms of a collaboration diagram. But we can also think of it in terms of choreography. So we focus on the interactions rather than basically the workflow in the pool. We're describing the dance. We're talking about who talks to whom in what order. Right? Remember, there's no centralized control and there's no centralized management of state. So a choreography diagram in BPMN tries to capture this idea of what a choreography is. Right? So it's basically what is the steps in the dance that occur between these two orchestrations. So it's depicted as a graph of flow elements, a message flow, which is a set of activities, events, and gateways, as before. So the way to read this diagram, you start with the left-hand side. We've got a start event, so we're starting whatever this choreography is. And you can see there's a grey line. So one of the actors, one of the pools here, essentially is greyed. And that means they are receiving a message. So the way we read the first one is customer sends a start shopping message. And shopping, because there's a box to the grey message, basically responds with a basket created response back to that message. So you can see the next one, customer basically adds an item which goes to shopping. Eventually the customer stops shopping. Well, actually, sorry. The basket basically says, when you added your item, I will price the basket and gives you back a basket price. Customer reviews the price, potentially keeps shopping. At some point, the customer says, I'm done and I want to check out. Gives us our address and payment details to basically the shopping pool, and effectively we end up saying, okay, we validated the basket and you can have your shopping. So it's looking at the interaction between the different pools, and it gives you a way to map that out. So for our example, that's what the choreography looks like. So effectively what happens is the customer effectively is placing an order with the pizza shop. The pizza shop decides that little gateway, am I going to accept or reject this order? Once it's basically got the order, effectively it confirms to the customer it's in the oven, and then essentially it says it creates a delivery manifest and sends it to a courier. The courier accepts or rejects the job, and as the courier's traveling, they will basically say, I'm on my way, making my journey, and I finally arrive to the customer. So that's what a choreography is. So there's a little bit of a problem here, which is typically lots of people in the EDA space say, orchestration is all about messaging or commands, and eventing is all about choreography. And honestly, that's pretty much nonsense, I'm afraid. Please don't repeat that one anymore. Orchestration is about somebody having control and managing the state of a given instantiation of a workflow, and it nearly always runs in process. Choreography is the stuff flowing between different orchestrations that has no one in charge of it and no one tracking it, right? Routing slips are when we basically try and do orchestrations in a distributed sense, and we'll talk about that a bit later. But choreography is this flow of control in between. Now, that's slightly a step back. There is an issue about event chaining, right? Where effectively what happens is that there's just, you've got a whole load of very tiny services, and you've effectively distributed your orchestration without explicitly doing a routing slip. So in other words, when we think about one of those flows we saw earlier, if every one of those tasks is a separate service, a kind of nanoservices problem, raising and creating events, you tend to end up with event chaining. It's very difficult to manage because essentially you have huge amounts of coupling between the various events. And you get basically a problem called event pinball, where effectively you kick off one event and you're really not certain what's going to happen. So adding an orchestration helps because it says this bit is under control, and if there are messages, this thing is controlling, at least from the point of view of one observer, what's happening. So you introduce control via those orchestrations. A lot of what you're doing is using, to use WS messaging terms, in-out, basically, which is request response. You have in-only as well, which is basically fire and forget, and robust in-only, which is fire and forget, but you do have a channel for errors. And it's important to have in-outs because they are causality. So in my workflow, running in my orchestration, I get to a step and I say, send a message, I'll wait for a response. I'll wait for the response before I get to the next step. So it's important, for example, generally as a business, that before I cook your pizza, you've paid me for it. Otherwise, that tends to be a very bad business and we go bust pretty fast, right? So there's causality required, so it's useful to have in-out between the pool effectively tending to run the shop front and the pool tending to do the payment provider, right? Where you say, I'm going to send you a message, you're going to respond and come back to me and tell me you paid for that particular pizza, and I will process the order, right? So causality is useful and helps to stop event chaining, and particularly when you start to think about in-out between various pools. Out only or pub sub is effectively usually better, or effectively at the end or beginning of a workflow, where effectively you're signaling my workflow is done, whoever cares about it, I'm going to inform you, or that during your workflow, there's a significant step has been achieved which other people may care about being notified about. All right. So, when we think about collaborations, typically when I'm doing some kind of in-out, I'm transferring control away from the workflow to another pool. From one pool to another, that pool is going to run and do some stuff. It's going to then return control to me. There may also be data involved. In-out, I expect it to return. In-only, fire and forget, I'm kind of done with my workflow, but rather than being an event, I know that you need to participate in the next step of the process, so I'm going to introduce some causality, because rather than have a passive-aggressive event, I'm going to tell you need to run next, right? Events typically only communicate the outcome and basically, or an interim state that's been achieved. So we can think about this as being a kind of in-out command that I'm sending in my choreography. These are really basically, that's an out only because I'm just introducing to a customer the idea, I'm signaling to them that I'm reached the key point of putting your pizza in the oven. This is in out because I'm asking couriers whether they can take my pizza. And these are out only because I'm signaling progress to the customer. All right. So it's a critical problem at the minute where effectively I think not enough people in event-driven architectures have got the distinction between orchestration and choreography right. And that has led, I think, to some bad event-based designs where effectively people have tried to do the orchestration in a highly distributed fashion, imagining that because they're using commands, it's all under control. Typically don't do that. Typically put your orchestration of the workflow inside a process, although it may call and interact with other services to get work done. You can also think about, because you start talking about AWS messaging, you can think about even in messaging, one of the participants is a provider, the API, one is a requester, the person wanting the API. It's not the same as producer-consumer, because if I'm receiving commands, I'm effectively the API owner, the provider. If I am sending command, but if I'm publishing basically facts, then there's the provider, I am basically the producer, so it varies. But you can see the whole model here of effectively a whole range of requesters and providers. We haven't got time to review it in depth. All right, so think about orchestration versus choreography, centralized versus decentralized, inside or between pools, one party's process, multi-party exchange, internal shared messages, protocol API calls, query, etc. All right. All right. I'll run through this next section quickly just for time. So there are a number of standard workflow patterns, which when you are effectively building your diagrams and thinking about your orchestrations, you can kind of lean on. There are, I think, probably about, documented in these two key papers, 30-odd patterns. You can just worry about the 5, right? The others are all particular variations useful for given circumstances, but as long as you're aware of the 5, it's pretty okay. Sequence, we kind of talked about that. One thing follows the other, 2 tasks consecutively. Parallel split, which is effectively this task becomes one of my other tasks, right? Synchronization or join, I'm joining together tasks. Exclusive choice, I'm going to branch and go one way or the other. And a simple merge, where effectively, rather than, that will also basically, you can join those back, right? But simple merge, where effectively I just say, rather than have an actual join condition to join back, actually, naturally, it will just go back without synchronization to a single flow at some point. All right, let's talk about automating business processes. So we've discussed how we kind of find them. We've discussed kind of how we think about them in terms of documentation, orchestrations, and choreography. How do you actually build that? So broadly, you need to think about 2 things: activities and resources. So typically, any kind of service owns both of those. So the resource is some kind of domain concept that we manage, like restaurants, couriers, customers, right? And the activity is a process that we are effectively running that potentially has some series of steps or states. So the process we've just been thinking about. So in response to a token moving through our flow, what happens is we make changes to our resources and we update our state of our activity. Where are we right now? All right? So the real implementation question for this is, well, how are we managing activities? The other real question you get into here is durable execution. So if I have a long-running process, which by implication we are saying some of these orchestrations are, it needs to survive restarts, handle retries and failures, resume after waiting, right? So we're going to need to persist that activity state so that effectively we will survive restarts for our operation. So the simplest kind of model is if basically you've got some kind of event-driven system where your framework just says, write a handler for the message when you receive it. Again, that's pretty much what Brighter does, right? And in that handler, what we expect you to do is modify your resource and update any activity state yourself. We're not giving any help. Typically, this is really useful when activity state is also effectively resource state. So when you think about some kind of aggregate model where effectively you think of the aggregate as some kind of state machine, right? Where effectively it can move through a sequence of states.
Because we're saying we're storing the state, it's durable, but the control flow is implicit. Typically, you don't act what's on the queue until effectively you have handled the message. That means if you fail before you've basically saved the change to the activity state, you will essentially just consume that message on startup. It's great for simple workflows, but logic can rapidly become complicated if you have a multi-step workflow where effectively each handler is handling a different portion of the workflow, right? It relies on guaranteed delivery to store work. It relies on transactional messaging in an outbox in order to basically be durable. And it rapidly gets complicated. So don't worry too much about the detail. It's mostly pseudocode. But typically, you're writing something like this. You've got some handler where effectively you're saying, oh, I've kind of received an order. I need to make a decision about what kind of event I'm going to send back out depending on stock. It's transactional messaging working with an outbox, and I'm going to move stuff on. So you write a lot of these, and it's perfectly viable as a way to build software. How do you handle failure? Generally, basically, you often do retries of the handler. You may have some kind of fallback mechanism which says, in the event my handler fails, run this code. And you kind of have some kind of reversing action which says, whatever I did in the handle method, just undo that, right? So typically, you match the two. Brighter, for example, has a fallback method as well as a handle method. And essentially, if you bubble out without after your retries with an exception, you can invoke the fallback method and say, run some reversal. Straightforward, but again, it becomes complicated if your workflow is complicated. And particularly what starts to happen with these is if you want to introduce things like gateways, so branching conditions and logic, it gets a bit gnarly to see what's going on. So the next sort of layer up is we have some kind of explicit state machine. And really, effectively, we say, I want to make explicit what is happening in the relationship between the handlers. So my state machine is effectively what my handlers treat as the activity, and they will, whenever they're signaled, tell the state machine, oh, this has happened, and the state machine will transition to a new state and may run some code as part of that transition. The state machine typically gets loaded from some kind of a correlation ID or conversation ID. You load that one up, and then you basically adjust the particular state of the state machine. All right, I'll take a few of those over. This is a kind of pseudo version of how, say, for example, mass transit works with its state machine, where effectively you are defining a series of steps, like initially, so initial state for the state machine, during, so here we're saying, initially when the order is submitted, basically send a message to look for the stock. When I receive a pending stock message, you're then making a decision to push something to another message, depending on whether or not things, whether you have the stock to cook the pizza. Compensation typically means in here, after you've done some retries, then I transition to a state which represents a failed state, and you're essentially then trying to get to something that is basically a safe state. Often when you're transitioning, you're running some kind of undo or reversal to reverse the operation that basically you've done. When people talk about the saga pattern, typically this is what they mean. Typically, they mean they have some kind of state machine which is enabling them to basically reverse pending transactions or rather reverse transactions that have happened in order to put resources back in the correct state and to put activities back in the correct state. Sometimes people only revert to the last good state. Sometimes they abandon the whole workflow. It depends on what your implementation is and what your choices are. Routing slips I mentioned briefly. So what are routing slips? So routing slips, I think of them as basically like REST for messaging. In REST, effectively, we push state back and forth between basically server and client to essentially say, this is the activity state, right? In messaging with routing slip, you're pretty much doing the same thing. You're saying there's nobody controlling, there's no central place that holds the state of this workflow, so I'll put the state in the message. And I'll transmit it with every message. I will transmit the state of the process. I will tell you what's been done, what is next, right? It gets complicated when effectively you want to do things like branching conditions, parallel splits, all those kind of things. Very difficult to achieve. Sequential workflow is kind of okay. I don't tend to recommend it that much. Similarly, basically, you have to have some idea about how you run your failure conditions, and typically, again, that's embedded into your description of the workflow and the process, and you have to say, okay, well, take this branching path instead. That's for time. I'm skipping going up and fast to get to the end. Workflow engines. So the next step up is to go to a full-on workflow engine. So a workflow engine is essentially something that's going to implement those key process diagram activities like sequence, join, split, merge, choice, right? And typically, they are a kind of open source product you buy or a commercial product that you buy, right? They may directly support BPMN. So you may actually have a visual design tool where you can go and design your BPMN workflow. Some of them explicitly do it by you just configure it in JSON or YAML. Others, you just do it directly in code. You write code, and the code basically forms your given workflow. It depends on the choice. Typically, steps in a workflow engine are what we call glue code. You don't write your domain logic in the step. If you're writing code, you call something else that contains the domain code. Right? Maybe basically have to wait. So if you have to wait basically for an event or a timer action to happen, typically what you need to be able to do is persist your workflow state, and then essentially when you get a message in, retrieve your workflow state. Workflow engines typically have some kind of scheduler, a job scheduler, which effectively now enables them to say, okay, which things are currently working and in flight, which things are currently paused and waiting for something to happen. Typically, you want that to be distributed such that any machine can pick up and resume any one of your workflows in case something crashes. That's why it tends not to be something you write yourself. It tends to be something you get a product for. Compensation is typically divided into business or technical errors. Business errors are just really a path, right? Like card declined. So typically it's just something you account for in your workflow. If card is declined, we take this route, right? Technical faults, typically, again, you try and handle them by a retry. If you fail to have a retry, quite often they allow an explicit catch clause to say, catch things that are bubbled out and take a particular fallback action. Sometimes if there's no catch, they will typically either fail the whole workflow or they will revert to the last persisted state and say, this is how far we got when we were good. We can't get past this step. There are two types of workflow engine. Some engines run in either context, embedded. So basically, you just run an instance of that in your code. You just new up something like a workflow engine. And when you new up your workflow engine, you add in your workflow. It'll be either summoning the JSON from a file to load in or writing the code. And external ones, where effectively you run a whole separate process, typically behind some kind of REST API, where you call it and load in your jobs, be they effectively, again, done by a BPMN diagram, or you write code to load some JSON into it, where effectively it runs externally to your individual code. All right. So the problem with the external ones is we learned in the era of SOA, when we all drifted towards service buses and things like BizTalk, that effectively they create this centralized piece that all of your teams need to go to and alter in order to essentially adjust their workflows. It's a single point of failure. It becomes difficult to maintain. There's a big separation in context when you're trying to think about what something does between the individual processes and the individual services and the process. But particularly what happens is you get anemic services, because typically the services just do CRUD over some resource now, whereas all of the activity is located inside your workflow engine. And really, we don't care mostly about CRUD, right? We don't really care about that state management. Our domain is really the process. So we've really offloaded the most important part of our domain away from the team, who now sit owning some CRUD interface, right? And that led basically to this admonition in microservices, smart endpoints and dumb pipes. That's where it comes from. It comes from people using external workflow engines. So ESB products often include sophisticated facilities of message routing, choreography, transformation, and applying business rules. The microservice community favors an alternate approach, smart endpoints and dumb pipes. And by that what they mean is run the workflow in one of your domain processes, not in an external engine. The main reason I think to use an external engine is if you have a number of processes like shopping, payment, delivery, and a courier, which all run their own individual orchestrations to handle their part, but you are concerned that the choreography that lies between them is complicated or unreliable, and you want to take control of it, then you might run an external workflow engine, if you like, to take that overarching process that lies between all of your individual bounded contexts. And that's where it's more worth doing. That's just a summary of that. And a quick summary slide. I'm just slightly over time, so I'm just going to give you that. But basically, my model is start with handlers. If I can't map it via handlers, move to a state machine. If I can't basically deal with it by a state machine, move to a workflow engine. Sometimes I go handlers to workflow engine because state machines are really just lightweight versions of workflow engines, right? It depends whether you find the state machine easier or harder to see. All right, that's our summary. Thank you very much.